All right, let's look at your review, starting with the self-test number 1. So here they want us to find the first 4 terms of the sequence and then determine whether it's arithmetic, geometric, or neither. So starting out with that recursive formula, we know the first term is 0, so that's taken care of for us. Now, what this is saying in this problem is we're taking the previous term, which right now would be 0, plus n squared. Well, right now we're dealing with I'm trying to find the second term because the first term was given to us, so I'm trying to find the second term. So n would be 2. So 2 squared would be 4, and 4 plus our previous term would just be 4. So our second term would be 4. So then to find our third term n would be 3. So we would take and square the 3, so 3 squared would be 9, plus the previous term. So 9 plus 4 would be 13. And then to find the fourth term in the sequence, we would square 4. So 4 squared would be 16. And 16 plus the previous term, well, the previous term is 13. So 16 plus 13 would be 29. So those are the first 4 terms of the sequence. Now, I'm not going to bother writing out the answer for part 2. We'll just talk about it. Because it says there is a sequence arithmetic, geometric, or neither. It is neither. Because the constant difference changes, okay, or I should say there is no constant difference, because going from 0 to 4 you would add 4, but 4 to 13 we would add 9, and so on. So there is no constant difference, and there's nothing you can multiply 0 by to get 4, so there is no constant ratio either. So there is no constant ratio, there is no constant difference, so it is not arithmetic or geometric. All right, let's look at number 3. It says the first term of an arithmetic sequence is -3, and the constant difference is d. Find the 12th term. So what we're going to do is we're going to use that formula where we're going to take d times n minus 1 plus our first term. Well, our constant difference is what we don't know. Okay, so that we're just going to stay a d. And find the 12th term. Well, that means n would be 12, so 12 minus 1 would be 11, plus our first term is -3. So if we simplify that, we would write that as 11d minus 3. That'd be your answer for number 3. All right, let's look at number 5 here. It says here we have consider the sequence t, which begins with t sub 1 equals 8 and t sub 2 equals 24. It says write an explicit formula for t sub n if t is an arithmetic sequence. So if t is an arithmetic sequence, we're going to use this formula. So it'd be, again, our d times n minus 1 plus our first term. So our constant difference we can figure out. Because if you take 24 minus 8, you get 16. And we know our first term is 8. So if I simplify that, so you could leave it like that, or we could simplify it. If I simplify that, we would distribute the 16 through. By the way, on the quiz and on the tests, you're needing to simplify these. So we want to simplify that. So we distribute the 16 through, so we get 16n. But then we take 16 times -1, which would be -16, and add 8, and -16 plus 8 would be -8. So our explicit formula would be 16 times n minus 8. Now our geometric formula would be to take the first term times r to the n minus 1 power. That's what it asks us to do in part B. It says write a recursive formula. Oh, if t is a geometric sequence. Okay, so we want a recursive formula. My bad. So if it's a recursive formula, if it's a geometric sequence, we would say the first term is 8. To find the next term of this sequence, we would take the previous term times what we'd multiply by, so our constant ratio. So 24 divided by 8 would be 3, so we're multiplying by 3 each time. And we would just say that we would use this for when n, I'll just write it like when n is greater than 1, or you could say greater than or equal to 2. That's just that n is greater than 1 piece. It's just referring to the fact that we already know the first term, so we would use that second line of that recursive formula after the first term. So that's number 5. All right, let's look at number 6. So for number 6, it says determine whether the sequence has a limit, and if it does, determine the limit. So for 6, we have 27 divided by n cubed. And so that's one where the value for the, or I should say the denominator has a larger degree than the degree in the numerator. So what that means is that the it does have a limit, and its limit would be 0. And again, the reason for that is because the degree is smaller in the numerator than the degree in the denominator, because the degree in the numerator would just be 0 because you don't have an n. So since the degree is, however you want to look at it, the degree is smaller on top or the degree is bigger on the bottom, your limit would be 0. If it was switched around and the n cubed is on top and 27 on the bottom, then there would be no limit. All right, number 7, it says the arithmetic sequence 213, 206, 199, 192, and so on. That arithmetic sequences don't have a limit because they just get smaller and smaller and smaller, so that does not have a limit. All right, let's look at number 8. Number 8 is asking us to find the sum of the first 4 terms of that series. So even though it doesn't give us that here, we know the fact that we're trying to find the sum of the first 4 terms that would go up to the 4th term. So here's what we know. First off, based on what's on the right here, that tells me that this is a geometric series. And so to find the sum of a geometric series, I need to find my first term and what my constant ratio is, and the number of terms. So I need to know my first term, my constant ratio, and the number of terms. So the number of terms is 4. So we have that. Whoops. So we have that figured out already. So now we just need to figure out, well, what's our first term going to be? First term is going to be since they give us the explicit formula there, the first term is 5, and we know the constant ratio is going to be 2 rather. So it's going to be our first term, which is 5, because again we get that from right here, and then 1 minus r to the n, so it would be 1 minus r was 2. Again, we get that from right here, and then the exponent is the number of terms, which is going to be the 4 terms. And all that is going to be divided by 1 minus 2, which will end up just being negative 1. So the numerator ends up becoming negative 75 divided by negative 1, so the sum of that series would be 75. That's your answer for number 8. All right, so for number 10 it says, does the infinite geometric series with first term 5 and common ratio of 1/3 converge? And if it is convergent, give its sum. Okay, now the first thing we need to recognize is that it is an infinite geometric series. So that means if our value for r, or our common ratio, is between negative 1 and 1, which it is, then it does converge. Because if it was bigger than 1 or smaller than negative 1, then it would not converge. It would be divergent. But otherwise, so this one, it does converge. So to figure out what it converges to, remember we use that formula where we're going to take, so to find the sum of an infinite series, we take g sub 1 divided by 1 minus r. So our first term they give us is 5, so it'll be 5 minus 1, or 5 divided by 1 minus 1/3. Now that's the same as, because 1 would be the same as 3 over 3, so this would be 2/3. Now what I want to do is I want to get rid of that fraction by multiplying the top and bottom by the reciprocal. So you end up getting 15 halves, or if you say 7.5, that's fine, but it's always best to make sure we're exact and use the fraction as our answer. So that's number 10. Number 12. Lester began running every day for exercise. The first day he ran a half a mile. The 10th day he ran 5 miles. If each day he increased his distance by a constant amount, how many miles did he run in all 10 days combined? All right. So here we know a couple things. We're trying to find how many miles combined. So that means that this is a series, and the fact that we have a constant amount that we're adding each time means that this is an arithmetic series. So to find the sum of an arithmetic series, we have 2 formulas that we could choose from. So we have this one, where we would take n divided by 2 times your first term plus your last term, or we could do, depending on what we're given, we could do this formula. We take n divided by 2 times your constant difference times n minus 1 plus 2 times your first term. So we've got to figure out, with what we're given, which formula would be the easiest to use. So we know that on the first day he ran 0.5 miles. Okay, so that's day 1. On the 10th day he ran 5 miles. And they don't tell us our constant distance, the constant difference there. They just tell us that it is going to be a constant amount. And so we know the first value, we know the last value, and we know the fact that it's going to be a total of 10 days. So this is going to be the formula we're going to want to use. So we would take n is 10, so we'd have 10 divided by 2. Yes, I know that's 5, but just so you understand where the 5 came from, I'll leave it like that. So 10 divided by 2, and then we would have On the first day, he ran a half a mile, and on the 10th day, he ran 5 miles. So this is just a problem where you just plug this in your calculator, and when you do that, you would take, again, you could just simplify it and just do 5 times 5.5, but you end up getting 27.5 as your answer. So total, the course of those 10 days, he'd run a total of 27.5 miles. All right, let's look at number 14. It says, suppose a particular computer loses 50% of its value each year and has an original value of $2,600. In what year will the value of the computer first become $100 or less? All right, so for this one, this is a depreciation problem. So it's losing 5% of its value each year. So we're going to take 100%, because that would represent the original value, minus 50% would be 50%. And so it's keeping 50% of its value. So I really don't care for this problem too much, because if it was any other percentage other than 50% and you just use it as a decimal, it'd be wrong. So just make sure that you remember you're subtracting 100% minus what it's depreciating by to get that value. So then if we set this up as an exponential function, because we know that our initial amount is 2,600 and our depreciation would be 0.5. Okay, or our growth factor would be 0.5. And then to the x power, we're trying to figure out how long it would take for it to first become $100 or less. So there's a couple ways that you could solve this problem. One way would be to graph this equation and this one to figure out at what point they would intersect at. So that would be one way to do it. The other way to do it would be to solve using logarithms. Because remember, we did this last chapter, so we could do what we just learned about last chapter, and that's what I'm going to do here. So to solve this, we would just take and divide both sides by 2,600. So we'd have 0.5 to the x power equals, if I divide by 2,600, I get 0.0385. I'll round that too. So to take and solve using logarithms, we could take the log of both sides, would be x times the log of 0.5 equals the log of 0.0385. So to find what x is, we would just divide both sides by the log of 0.5. So 0.0385 divided by the log of 0.5. And when you do that on your calculator, you get approximately 4.7 years. So a little over 4.7 years, it would be $100 or less. Would be your answer for number 14. Again, you could do that using guess and check, which would be a little harder. Otherwise, the other method that I would choose other than using logarithms would be to graph this as two separate equations and find where they intersect. All right, let's look at this next section. So the next section now is moving to the review part of this review, because the way the book sets it up is it sets it up in the self-test and the chapter review. But anyhow, the first 4 terms in an arithmetic sequence are 96, 77, 58, and 39. So you want to find out what the nth term is and what the 50th term would be. So what they mean by that first part there, finding the nth term, is we want to find an explicit formula that we could use to figure out any term in the sequence. So again, this is a arithmetic sequence, so we know that one of the things that we need to find is we need to find the constant difference. So to do that, we could just take any term in the sequence and subtract the one before it. So 77 minus 96 would be negative 19. So our constant difference is negative 19. We know our first term is 96. And so what we're going to do is we're going to set this up to say that a sub n equals our constant difference, which is negative 19, times n minus 1, plus the first term, which is 96. Now, you could simplify that, which is what I want you to do on the test. It would be negative 19n. And then I would take negative 19 times 1, which is positive 19, and then combine that with 96, and I get 115. So this would be my best explicit formula to find any term in the sequence. So now the second part, when it says part B, when it says find the 50th term, we would just take negative 19 times 50 and add 115. So negative 19, multiply that times 50, add 115, and I get negative 835. So that would be your answer for 5B. All right, so 6 is going to be very similar. So for number 6, they ask you to find, again, they give us the first 3 terms of a geometric sequence, and we need to find the nth term and the 15th term. So to find the nth term, again, we're trying to find an explicit formula. So I need to know what's the first term in the sequence. Well, that's 36. The other thing I need to do is figure out, well, what's their constant ratio. Well, if I take negative 72 divided by 36, I get negative 2. So our constant ratio is negative 2. So I would have our first term, which is 36, times our constant ratio, which is negative 2. Then our exponent's going to be n minus 1. So to find the 15th term, we would just take 36 times negative 2. Then we'd have 15 minus 1, which, yes, I know that's 14. So on your calculator, just save yourself some time and just use 14 as your exponent. And when you do that, you get 589,824 as your answer. All right, so number 7. Number 7 had asked for an explicit formula for the sequence defined by, so we got the first term is 11,000. And then we're taking 0.7 times n minus 1. So that gives away there that it is a geometric sequence. And we know our first term is 11,000. So you could say, well, since I did r sub n, I'm just going to do r sub n. It doesn't matter what letter we use. But we'll just stick to the r's here. So our first term is 11,000 times our constant ratio, which is that 0.7 to the n minus 1 power would be your equation, your explicit formula for number 7. All right, let's look at number 8. So number 8, it says, give a recursive formula for a sequence defined by a sub n equals 64 minus 6n. So another way to look at that would be to say that it's negative 6n plus 64, if you wanted to look at it that way. So anyhow, we need to figure out, well, what's our first term? Our first term is when n is 1. So if I put 1 in there for n, negative 6 plus 64 would be 58. So we know our first term would be 58. And then to find the next term of the sequence, we would take the previous term, and the constant difference is our slope, or whatever is being multiplied times n. So we would be decreasing by 6 each time, so minus 6. So we could follow that by saying that your value for n has to be greater than 1, or you could say greater than or equal to 2. All right, let's look at number 9. Number 9 to give us that the third term of a sequence is 12, the fifth term is 24, and we want to find the fourth term and a formula for the nth term of the sequence if it's starting with this if it's arithmetic. So what we can do is we can treat this as, remember, two coordinates. So we know the third term is 12, and the fifth term is 24. So what we could do is we could find the slope, and that would give us our constant difference. So we would do 24 minus 12 divided by 5 minus 3. 24 minus 12 would be 12. 5 minus 3 would be 2. So our constant difference is 6. So if that's the case, to find the fourth term, we would just take and add 6 to our third term. And our third term is 12. So the fourth term would be 18. Now, I forgot to mention this before, but you don't have to worry about finding the nth term of the sequence. That just gets a little bit more complicated with this one because we don't know the first term, so you'd have to go through a process to figure out the first term and then find the explicit formula for the sequence. So for both of these, for 9 and 10, all I care about is that you know how to find the fourth term. So let's do that now for number 10. So now number 10, if it's a geometric sequence, remember that means to find the fourth term, we're going to find the geometric mean of the two values. And the two values would be 12 and 24. So if I take the square, so 12 times 24 would be 288. And then if I take the square root of 288, I get 16.97. It keeps going on, but we'll just leave it like that. So the fourth term, if we treat it as a geometric sequence, would be approximately 16.97. And again, you didn't have to do the second part of number 9 or 10. All right, let's look at number 11. So it says an arithmetic or geometric series is given. Write the series using sigma notation and then evaluate it. So for each of these, we need to figure out first, what do they represent? Do they represent a geometric or arithmetic series, and then give the right formula for it? Okay, so with this first one, I see going from 59 to 75 and from 75 to 91. If I wanted to figure out if it's a arithmetic sequence, I would just figure out, well, what would we add 50 to 59 to get 75? So just take 75 minus 59. When you do that, you get 16. Now, if you were to take 91 minus 75, guess what? You also get 16. Or 107 minus 91 is also 16. So this is an arithmetic sequence. So we need to figure out a couple of things here. We need to first figure out, well, how many terms are there total? So we know that 171 is the last term. So we can use our explicit formula where we know the constant difference is 16 times n minus 1. So again, I'm trying to figure out what value for n would give me an answer of 171. So that's why we can use this formula to solve for n. And then we know our first term is 59. So if I simplify that, I would distribute the 16 through. So we'd have 16n, and 16 times negative 1 is negative 16. And so if I took negative 16 plus 59, we would get 43. And then I would solve for, again, I'm trying to solve for n, so I subtract 43 from both sides, and you get 128. So now to solve for n, we would take 128 divided by 16. And you get 8. So that means that 171 is the 8th term in that series. Okay, so that was a lot of work just to find out what n would be. So now we can write our explicit formula that would give us those values in that series, and that's what would go to the right. So we would have our constant difference, which was 16 times n minus 1 plus 59. Or if you simplified it, again, if you simplified that, that would be 16n, and then 16 times negative 1 would be negative 16, and negative 16 plus 59 was 43. So if you said this, that would be fine as well. All right, so that would be your sigma notation for part A. So now to evaluate that, that means we're actually going to find the sum of the series. And remember, to find the sum of a series, we just need two things for the easiest formula. And that's if we just know the first term and the last term. So we know the first term is 59, and we know the last term is 171, and we know that there's a total of 8 terms in the series now. So we would just take 8 divided by 2, which I know would be 4, and then we would have 59 plus 171. So when you do that on your calculator, you get 920 as your answer. So the sum of that series for number 11 would be 920. All right, let's look at number 13 here. So number 13, this one's actually a little bit easier for us because we see that we have 1 to the, so our first term is 1, then we have 4, then 16, then 64. So what's happening here is this would be the same as 4 to the 0 power, 4 to the first power, 4 to the second power, 4 cubed, all the way up to 4 to the 11th power. Now you might think that means that there's 11 terms in the sequence. Well, that would be wrong because we're not, if we do that, we're not counting that first one, 4 to the 0 power. So we have to count those 11 plus that 4 to the 0 power. So there's actually 12 items, or 12 terms in this series. So this is a geometric series because, again, we're multiplying times, or we're going from 1 to 4 to 16 to 64. So you can see your constant ratio is just 4. So our explicit formula would be 1, which really doesn't matter, times your constant, which is 4, and then to the n minus 1 power. So that would be the equation that would give us those values. So again, since we're dealing with a geometric series, though, so to find the sum of a geometric series, we would take g sub 1 times 1 minus r to the nth power, all divided by 1 minus r. So our first term, again, is 1. Really doesn't affect anything. We'll have 1 minus our constant ratio, which is 4, to the, and there's 12 terms, so it'll be 4 to the 12th power, all divided by 1 minus 4. And when you do that on your calculators, your final answer for that will end up being 5,592,405. Be your answer for 13B. All right, let's look at number 14. So for 14, it's going to stay as an equation. So we see here that, again, this would be r to the 0 power, meaning that we would just have, I'll do n equals 1. So we would have a total of 12 plus that one. So we would have a total of 13 items in that set. And so again, our constant ratio is just 1 here. So we'd have r to the n minus 1 power would be your sigma notation. So to evaluate it in part B, this one, it's just going to stay the formula. And you could just have, again, 1 times 1 minus r to the nth power, which is going to be to the 12th power. I'm sorry, no, 13th power. My bad. Divided by 1 minus r. So we could just leave it like that. So that would be your answer for part B. All right, so here we're dealing with another sum of an arithmetic series. So it says evaluate the sum of the first 81 terms. And so that means that that would be 81 up there. So we know we could find the first term and the last term. So to find the first term in that series, we would take 3 times 1 minus 11. Well, 3 times 1 is 3, minus 11 is negative 8. To find the last term in that series, we would take 3 times 81 minus 11. And so when you do that on your calculator, you end up getting 232. So the reason why I did that is so now it makes it really easy to find the sum of that series. Because then all we need to do is we just need to take n divided by 2, which would be there's 81 terms, times our first term, which we found to be negative 8, plus our last term, which we found to be 232. And when you do that for number 15, you end up getting 9,072. That's a 7. 9,072 is your answer. There we go. For number 15. All right, let's look at number 16. So for number 16, this one is a geometric sequence. So to find the sum of a geometric series, rather, we need to know our first term, which we can get that as 10. So we would take our first term, which is 10, times 1 minus r, so we have 1 minus 0.7. And then we want to find the 14th term, so it'll be 14. Oops. There we go. So we 1 minus 0.7 to the 14th power. N is 14 here. And then we divide by 1 minus 0.7. When you do that on your calculator, we can find the sum of those first 14 terms then to be 33.107. Be your answer for 16. All right, let's look at numbers 17 and 17 through 22 here. So for these, we're just going to classify them as arithmetic, geometric. They could be possibly those two items, or definitely those two items, or neither. Now, I'm really not too concerned about possibly or definitely arithmetic. The only reason why they say possibly is because we don't see the entire thing. So we'll just ignore the fact that it's possibly or definitely and just look to see are they arithmetic, geometric, or neither. So for the first one, going from 7 to 20, I would add 13. 20 plus 13 is 33. 33 plus 13 is 46. So from what I can tell, this is an arithmetic sequence. For number 18, this one is going from 33 to 39, I would add 6. But 39 plus 6 is 45. And so this is not arithmetic. If I wanted to see if it was geometric, I would take 39 divided by 33. When I do that, I get an ugly decimal of 1.18181818 and keeps repeating. But if I take 46 divided by 39, I do not get the same answer. I get 1.179. So it is not the same. So this would be neither. All right, looking at number 20. 20 would give us a recursive formula. But this recursive formula looks like nothing we've seen for arithmetic or geometric. So just by looking at that, I could tell if that's going to be neither. If you wanted to, you could find the first few terms of the series, or the sequence rather, and then you'd be able to tell also that it's not geometric or arithmetic. Now the next one, the fact that this follows the explicit formula for a geometric sequence tells me that this would be definitely geometric. So that's only one that would be definitely, only because we have the explicit formula there. Actually, we have sub 22, so I guess this could be definitely something as well. So number 22 is, it says a sequence in which each term after the first is 2 greater than the previous term. Well, if it's 2 greater, that means that you're adding 2 each time. And so if that's the case, then that's describing a recursive formula basically for an arithmetic sequence. So technically that would definitely be arithmetic. So though it's only going to be definitely geometric or arithmetic if we can derive the exact formula. But for this one, for number 17, even though we can derive a formula, they're not giving us the formula. So just by giving those first 4, it's possibly arithmetic. But again, I don't care about possibly or definitely. All I care about is, could it be arithmetic, geometric, or neither? All right, let's look at number 27. So with 27 and 28, we're just trying to find the limit. I don't care for number 27 if you use limit notation or not. I just care that you know how to find the limit of this expression. So when we look at that expression, again, if the degree in the numerator and the denominator is the same, then what we do is we just work with the leading coefficients of those 2 terms. And so our answer would just be 5/3. And so if you were to graph that out, the end behavior would get closer and closer to 5/3. Looking at number 28, the fact that your degree in the numerator is bigger than the degree in the denominator means that there is no limit for number 28. Now with number 32, this is a infinite series. The reason why we could tell that is because of the top there has the infinity symbol. And so we're trying to find the sum of a geometric infinite series. The reason why I could tell it's geometric is because of the formula that we have there. So remember, to find the sum of a geometric series, we just use this simple formula where we take the first term divided by 1 minus r. Well, the first term is, just erase some things here, the first term is just this 10. Okay, so we know the first term is going to be 10. Our constant ratio is the 0.7. Okay, that's what our common ratio would be, is 0.7. So if I take 10 divided by 1 minus 0.7, or 10 divided by 0.3, we get 33.3 repeating. So that would be the sum of that series. All right, number 34, it says, suppose you have $850 from a graduation party each week after that. Okay, now this one's tricky. If you got 1,070 as your answer, it's because you didn't catch this little piece of the sentence. Each week after that, your allowance adds an additional $20 per week of savings. How much total savings will you have at the end of this 12th week? Okay, so at the end of the first week, they would have you would have $870 in your account, because $850 is before your parents started depositing your allowance into your account. So you got $850 from graduation, and then each week after that. So after the first week, so we could even do W sub 1 to represent after the first week, you'd have $870. All right, so now this is an arithmetic series, or sequence. And so what we would do is to find how much there would be at the end of the 12th week, so we could say W sub 12, we would take our constant difference, which is $20, is what's adding each week, and then week 12 is what we're trying to find, and then our first week we had $870. So when you do this on your calculator, you end up getting $1,090 as your answer. So that is the correct answer. If you got 1,070, it's because that instead of using how much they had after the first week, you used how much they had after graduation. All right, let's look at 35. In 35, it says a theater has 15 seats in the first row and 3 more seats in each subsequent row. If the last row has 27 seats, how many rows are in the theater? All right, so this is one, this is one where it is not a sum of a series. Okay, so we're not trying to find the total number of seats, we're trying to figure out how many total rows there are. And so we're going to use our formula for or explicit formula for an arithmetic sequence, which is this, because here's what we know. We know that in the first row there's 15 seats, and there's 3 more seats in each subsequent row, so that's our constant difference. We know that the last row has 27 seats, so that's A sub n. And we want to figure out how many rows are in the theater, so we're trying to figure out what n is. So we know that there's a total of 27 seats in the last row. When the constant difference is 3, we want to figure out how many rows there would be if we know that the first row has 15 seats. So if I solve this equation, we would have 3n. If I distribute the 3 through, we'd have 3n, and 3n minus 1 would obviously be negative 3, but plus 15, that would be 12. So what I would do is I would subtract 12 from both sides, and I would have 15 equals 3n. So if I divide both sides by 3, I get that n equals 5. So we would have it there to be 5 rows of seats in that theater. All right, let's look at number 36. It says if there are 15 rows of cans, how many cans? Oh, let's read the instructions. It says, suppose that a display of cans in a supermarket is built with 1 can on top, 2 cans in the second row, and 1 more each succeeding row. If there are 15 rows of cans, how many cans are in the display? So this one is the sum of a series. We're trying to figure out how many total cans there are. In the previous one, that was not the case. We weren't trying to figure out how many total seats there were. We were trying to find out how many rows. And this one, we want to know how many total cans there are in the display. So this is, like I said, an arithmetic series. And there's 2 different equations. Remember, one where we know the first term and the last term. And that's what we know here. We know, oh no, we don't know that. We don't know how many rows are in the last row. So this is one where we have to use a longer formula. So it's this one, where we take the number of rows, in this case it would be the number of rows, times your constant difference, which we know that, times n minus 1 plus 2 times however many we have in the first row, in the first term. Okay, so let's see what we have here. We know that there's 15 rows of cans, so n is 15. We know that in the first row, in the top row, there's just 1 can. And we know the constant difference is that there's 1 more can in each succeeding row. So that would be, the d would be 1. So let's plug all this in. So we would have 15 divided by 2, which I know is 7.5. Then we'd have 1 times, which we don't care about that. N is 15, so we'd have 15 minus 1 plus 2 times our first, so 2 times 1 are just 2. Okay, now we could simplify inside of parentheses there. 15 minus 1 is 14, and 2 times 1 is obviously 2. So we would have 7.5 times 16, because we'd have 14 plus 2, which would be 16. So when you do that, when you take 7.5 times 16, we get 120 cans. So it would be 120 cans in the display. All right, let's look at 38. So for 38, it says that in training for a marathon, an athlete runs 7,000 meters on the first day, 7,600 meters on the next day, and so on. Each day running 600 meters more than on the previous day. How far will the athlete have run in all at the end of 30 days? Okay, so this one's very similar to the one that we just did. So we're going to use that same formula as what we used in this one. So we know, so again, there's going to be 30 days. So n is 30, so we'd have 30 divided by 2, which, yes, I know that's 15. We'll simplify that next. We know our constant difference. Each day they're running 600 meters more than the previous day, so we'd have 600 times n minus 1. So again, 30 minus 1, which I know is going to be 29, plus twice, or 2 times, the first term. And on the first day, they ran 7,000 meters. All right, so let's simplify that. So we'd have 600, inside of parentheses, we'd have 600 times 29 plus 14,000. So when you do all that on your calculator, you end up getting 471,000 meters. That's how far they will have ran total in those 30 days. All right, let's end with number 39. A certain car loses 21% of its value each year with an original cost of $24,800. Find the value of the car after 1 year, then write an explicit formula for the value of the car after n years. Okay, so it loses 21% of its value each year. So that means it keeps, if you take 100 minus 21, we'd have 79%. So it retains 79% of its value. So to figure out the value of the car after 1 year, we would take 24,800 times that 0.79. When you do that, we get $19,592. So that would be your answer for part A. All right, for part B, there's two possible equations that we could use. One would be using the original 24,800. So if we did that, so our explicit formula would be 24,800 times 0.79 to the nth power. Or if you're going to use this number, then we'd have 19,592 times 0.79 to the n minus 1 power. Okay, so both of those, either one of those would be correct. Typically, I like using the one where we just have n as our exponent. In that case, 24,800 would be our initial amount, our starting amount. Otherwise, if we do it after the first year, then we would have we would use the 19,592 and 0.79 times 0.79 to the n minus 1 power. But personally, I think the first one is a better equation. But both of them would actually be the same. And you could always test it out. Like, for example, if you did n for 1, so that means after the first year, what would it be? Well, if we put 1 in for n in this first equation, 24,800 times 0.79 to the first power would give you 19,592. If we use a second equation, we wanted to figure out how much it would be after the first year. If I put 1 in there for n, 1 minus 1 would be 0, and 0.79 to the 0 power would just be 1, which would give you 19,592. So that's why I say that either one of those would give us the correct sequence.